Okay, right, so looking at comparing coefficients. So our algebraic identities, it wants us to write this here, so 1 over x plus 2 times x minus 3 as partial fractions. So something with x plus 2 in the denominator and something with x minus 3 in the denominator. So it basically is asking us what is 1 over x plus 2 times x minus 3. What is that equal to if those two things are separate in the denominator? Okay, so they're giving it to us with those unknowns. Okay, so if we can figure out what those unknowns are, then that is super. Because then if we know what A is, if we know what B is, we can just fill them in here and here and have it written as two partial fractions. Okay, so when we're comparing coefficients, guys, remember, we always want to get the two sides of the equals to have the same form. Okay, so this is one big fraction, whereas this is two separate ones. Okay, so do I know how to make this one big fraction? Do I know how to merge those denominators? Yes. So I'm going to start by doing that. Okay, I'm going to rewrite this right-hand side with common denominators so that I can merge those numerators together. Okay, so if I wanted to come up with a common denominator here, the new denominator would be x plus 2 times x minus 3. Okay, now this is not by chance that it is the exact denominator that they wanted us to have. Okay, that is the denominator that we are coming up with, and that way we are going to be able to merge the a and b together and we'll have the same denominator on both sides. So the first thing I had was an a over an x plus 2, and then I had a b over an x minus 3. Okay, so this had to be multiplied by an x minus 3, which means the numerator also has to be multiplied by an x minus 3. And then this here has to be multiplied by an x plus 2. So the numerator also has to be multiplied by x plus 2. Okay, so now that we have a common denominator there, I can write out the denominator once on the right hand side. Okay, so once, so x plus 2 by x minus 3, and then I can just put everything from the numerators together on this top line. So I have an a by x minus 3 plus a b by x plus 2. Okay, so that's all on the top line there. Now, a few different things. Okay, I've now gotten them in the same form. Okay, same denominators, one big fraction over here, one big fraction over here. So I can compare the two things that are in the different forms. So I can compare the top line here with the top line here. Or alternatively, you can think about this in terms of fractions and think, okay, I have a common denominator across the board with an equals here, so I can cancel the denominators. Okay, or I can multiply across by the x plus 2 and the x minus 3. Okay, so I can start ignoring those denominators, and I can just think about this as 1 is equal to a by x minus 3 plus b times x plus 2. Okay, so I can start thinking about it like that. Now, this is for all values of x that this has to be true. Okay, so it doesn't matter whether x is 0.7, whether it's minus a half, okay, whether it's minus 2, minus 1, 0, 1, 2, 3, 4, 5, okay, it doesn't matter what x is, this has to be true. So I need to figure out what a is, I need to figure out what b is. Okay, I have two unknowns here, so I can't solve for both of them. Okay, but what's really nice here is we just said this has to be true for no matter what x is. So I can make x equal to something that will make the a disappear, and I can just focus on the b. Likewise, I could make the x equal something that would make the b disappear, and let me find what a is equal to. Okay, so how could I get, let's say, the a to disappear here? What would I need to multiply it by? I would need to multiply it by 0. Okay, so I need to multiply a by 0. So what does x have to be to make a be multiplying by 0? It would have to be equal to 3. Okay, so we're going to do this out and let x see how it works out when x is equal to 3. So we're going to get 1 is equal to a times 3 minus 3 plus b times x plus 2. Okay, sorry, not x, because we've just said what x is. So by 3 plus 2. Okay, so now I can see that it's 1 is equal to 0 plus b times 5. Okay, or 1 is equal to 5b. If I want to know what b is now, the only thing I have to get rid of is that 5 that is multiplying. So I divide by 5. So I get that 1/5 is b. Okay, I'm going to do the same thing again because I've only found b there. So I'm going to do the same thing but getting the b part to disappear. Okay, so here, how will I get b to be multiplied by 0? Well, we have to let x equal to a minus 2. Okay, so again, let's do out this equation. We'll get 1 is equal to a times minus 2 minus 3 plus b times minus 2 plus 2. Okay, so 1 is equal to a by minus 5 plus 0. Okay, because b is multiplying by 0, so that's 0. Okay, so if I have that 1 is minus 5a, I have to get rid of the minus 5. That is multiplying by the a, so I am dividing by a minus 5, which gives me minus 1/5 is equal to a. Okay, so we have now found what b is. We have found what a is. Don't forget the question is not finished because it wants this fraction up here to actually be written out. Okay, so if we have a 5th here where a is, okay, that means that it is a 1 on the top line and a 5 on the bottom line. So my partial fractions, so if I write this out in a full equation, okay, we have that 1 times x plus 2 and x minus 3 is going to give me, so where the a was, I'm going to have a minus. Okay, for the minus 1/5. The 1 is on the numerator, the 5 is on the denominator. Okay, and then we still have the x plus 2. And then for the b, we have a plus 1/5. So plus, we have 1 on the numerator, 5 on the denominator, and then my x minus 3.